Are you wondering what the difference is between Python.py files and .pyc files? You are in the right place. Files with .py extension are Python source files. In other words, files in which you write your Python code. The Python code you write in .py files is not executed in the same format by the machine on which you run your code. Before being executed, the code in the .py files is compiled into .pyc files. Imagine the compilation process as a translation from one language to another language. Files with .pyc extension are the result of compiling files with .py extension. A .pyc file for a given Python module gets automatically created when that module is imported. As a Python developer, you will only make code changes to .py files. To see the difference between the two types of files, let's create first a Python module in a file called app.py. For all the examples in this video, I'm creating app.py inside the directory /var/tmp. Also, app.py contains code for the app module, and in this example it contains a single function. To show you the format of a .pyc file, we will first use Python 2. You will understand why later in this video. Now, open the Python shell and import the app module. When you exit the Python shell, you will notice that the file app.pyc has been created. Let's have a look at the content of the .pyc file. The file is not fully readable because it's a compiled version of the original .py file. The file app.pyc contains bytecode. But what is bytecode? Think about bytecode as a low-level representation of the Python code in your .py file. Low-level means that it's nearer to the language that a computer can understand compared to the original Python code. But what creates compiled Python files? The answer is that it depends on the Python implementation you're using. The reference implementation of Python is called CPython and is written in C and Python. In this implementation, Python code is compiled into bytecode by a compiler before being interpreted. To verify the Python implementation you are using on your machine, you can use the Python platform module, and specifically the function python_implementation. Let's see what Python 2 implementation I use on this machine. The Python implementation on this machine is CPython, that as explained before is the reference implementation of Python. Also, let's see what the output is for Python 3. It's the same implementation, CPython. So far, we have seen that when using Python 2, the .pyc file has been created in the same directory of the .py file when importing the module. Given that Python 2 is very old, you should really use Python 3. In this video, I'm also using Python 2 just to show you the difference in behavior between the two versions of Python. Let's try to do the same test we've done before with Python 3. Delete the .pyc file created before and open the Python shell using Python 3. Then import the app module. Now exit from the Python shell and verify if a new .pyc file exists. For some reason, the compiled file with extension .pyc doesn't exist. But why? That's because in Python 3, the compiled version of the code for a given module is created in a different location compared to what happens with Python 2. Let's reopen the Python 3 shell and I will show you something. After importing the app module, we can use the dir built-in function to get a list of module attributes we can access. The attribute I want you to focus on is __cached__, also called dunder cached. The dunder cached attribute for a Python module is the path of the compiled version of that module. The addition of this attribute was a proposal part of PEP 3147, where PEP stands for Python Enhancement Proposals. You can see that the format of the name of the .pyc file has changed compared to Python 2. When using Python 3, the file name also contains the Python implementation, CPython, and the version of Python, 3.8. The file path depends on your operating system. Let's verify that the file app.cpython-38.pyc is actually in that directory. It would have been a lot harder to find this path without retrieving the value of the attribute dunder cached. Let's continue working on the example we've seen before. We want to understand when .pyc files get updated. Reopen the Python 3 shell, import the app module, and check if anything has changed with the .pyc file. As you can see from the output of the ls command, file size and last modified date for app.cpython-38.pyc have not changed. Now let's modify the Python function defined in app.py. We will change the name of the function from getFullName to getUserFullName. Open the Python 3 shell, import the app module, and exit from the shell. Verify if anything has changed with the compiled file app.cpython-38.pyc. Both file size and last modified date have changed, and that's because the Python interpreter has detected a change in the module app.py and has recompiled the code into a new .pyc file. So to recap, Python recreates the .pyc file for a given module when that module is modified and reimported. I'm also wondering, can you delete .pyc files? And the answer is yes. You can delete .pyc files, and if you do that and then you import that module again, the .pyc file related to that module gets recreated. Here you can see the .pyc file created before. Let's delete it and import the app module again. As you can see, Python has recreated the .pyc file by compiling the .py file. Now let's verify if we can delete the .py file with Python 2. Let's try to delete the app.py file, that is the file that contains our Python code. What do you think will happen when we try to import the app module? Before deleting the .py file, let's make sure the .pyc file exists in the same directory of the .py file. Now delete app.py and reopen the Python 2 shell to import the app module. That's interesting. After deleting a .py file, the Python 2 interpreter doesn't throw any errors when importing that module if a .pyc file for that module exists. Now let's try to do the same experiment with Python 3. Let's try to delete the .py file. The file app.py doesn't exist already in the directory /var/tmp, so we can just open the Python 3 shell and try to import the app module. We get back a weird error, bad magic number in app. What's the meaning of this error? One scenario in which the bad magic number error occurs is when Python 3 tries to load a .pyc file compiled with Python 2. Apparently this is happening here because Python 3 finds a .pyc file in the current directory and it tries to load it. Let's remove the .pyc file from the current directory and then try to import the app module again. This time we receive a module not found error despite the fact that the .pyc file still exists in the directory in which it was created before with Python 3. Now you know the difference between a .py and a .pyc file in Python. You also know what role .pyc files play in the execution of your Python programs. They are generated by compiling .py files and then they are interpreted. We have also seen how the compilation of .pyc files changes between Python 2 and Python 3. If you are new to Python, I recommend to go through a tutorial I will link in the description below. If you have learned something in this video, give it a like. And if you don't want to miss any of the Python tips I will be sharing in my future videos, subscribe to this channel. Thank you for watching this video and see you in the next one.